In this video, I'm going to be taking a look at solving exponential equations using logarithms. In other words, by taking the natural log of both sides. Something that I might want to point out is, though, that you do always want to make sure you isolate that exponential expression and then take the natural log of both sides. All right, it's going to make the equation work out a whole lot easier. Okay. Now, you usually use this method when you cannot get the bases alike. All right, so like on this one here, I've got 2 to the x equals 5. There's no way that I can make 2 and 5 have the same base. Like I can't rewrite 5 as a base of 2, in which case then that means I have to have another alternate method, and taking the log of both sides, taking the natural log of both sides is a way to do that. Okay, so hopefully at this point you do remember like lots of your properties and all that kind of stuff, because we will apply them as we go throughout solving this. Alright, so since I cannot make these bases alike, then I'm going to automatically take the log of both sides. So I'm going to go, and I'm going to use natural log, so I'm going to do natural log of 2 to the x equals natural log of 5. Alright, and then one of our properties of logs says that we can take that exponent and move it down in front. Okay, so when I do that, then I've got x times that natural log of 2 is equal to the natural log of 5. Alright, at that point, these are just like ordinary numbers. Alright, I'm doing x times a quantity equals another quantity, and I want to solve for x. So then that means I'm going to divide both sides of the equation by that quantity. So divide by the natural log of 2 and divide by that natural log of 2. Alright, natural log of 2's cross out. Okay, now we are going to get an exact answer if we leave it like this. So our x equals natural log of 5 over natural log of 2. That right there would be an exact solution. Okay, a lot of times textbooks will ask for that exact solution, and then they also want you to put it in a graphing calculator or put it in a calculator and get a decimal equivalent. Alright, if you did that, x would be approximately 2.322. Alright, and then that would be my approximate solution. You might want to pause the video and see if you can actually plug that into your calculator and get that as a decimal approximation for that. Alright, but generally 2 answers every time you do these because of this exact answer and the approximate answer. Okay, and then on this one over here, I put this example in just because of this part where I said, okay, you want to isolate that exponential expression before you take the log of both sides. Alright, here's my exponential expression, but it's got something extra on the left-hand side with it. 8 times 8 is also on that side. You could have a plus 3 on this side, or a plus 4, or plus 5. You're going to want to get rid of all those extra numbers before you take the log of both sides. Alright, so since I am multiplying by 8, then I'm going to divide by 8 and divide by 8. Now, generally what I do is I do not get in a hurry about grabbing a calculator. That 5 divided by 8, I don't necessarily want it to be a decimal, so I'm just going to leave it as 5/8, which is perfectly fine. So at this point then I'm going to have 3 raised to the x equals a 5/8. Just going to leave it like that. Alright, now I obviously cannot make like bases, so I couldn't do it any other way. I'm going to need to take the natural log of both sides. So then I'm going to have the natural log of 3 to the x equals natural log of that 5/8. And it's okay you have a fraction in there. Just leave it and don't worry about it right now. Okay, now this x, remember again, we have property of logarithms that says I can pull that down in front. So then I'm going to have x times the natural log of 3 is equal to the natural log of 5/8. Alright, again, x is being multiplied by that natural log of 3, so I can divide both sides by that natural log of 3. Alright, and so let's go divide by the natural log of 3 and divide by the natural log of 3. Natural log of 3's are going to cross out. Okay, so now I think I'm going to come up here and finish this. Alright, so I'm for my exact solution. Then I'm going to have x is equal to the natural log of 5/8 over the natural log of 3. Okay, and that's perfectly acceptable. And then you're probably going to be required to come up with an approximate solution in which case you'll have to grab your calculator. Alright, so again, you might want to pause the video, see if you can put this in your calculator and get the appropriate decimal. But I got approximately negative 0.428 for that one. Okay. Alright, so there's just a couple. Alright, now let's step it up a little bit because those were both kind of relatively simple, straightforward, not very complicated. Okay, so if we move it up to maybe something that looks like this. Maybe we've got a 5 raised to the x minus 2, so the whole exponent is x minus 2, and a 3 raised to the 3x plus 2. Okay, so something that you do want to acknowledge is that these exponents really are binomials. So we're going to have to keep them together. Okay, they are isolated. I'm not multiplying or adding anything in addition to either one of these on either side, so that means I can right away take the natural log of both sides. So natural log of a 5, and I'm just going to go ahead and put those set of parentheses, those binomials in my set of parentheses in black, x minus 2. That's going to help me remember to keep it together, to keep it a binomial. Natural log of 3, then raised to the 3x plus 2. Alright, and properties of logs then allow you to bring those binomials down in front. Okay, so then I'm going to have an x minus 2 times that natural log of 5, and this binomial in front, 3x plus 2, with a natural log of 3. Alright, now from here it's just going to be a lot of algebra steps. Okay, I've got a set of parentheses and I've got a number multiplied on the outside. Same thing on this right hand side. So then I can, let's switch colors because we don't want to keep doing this in red. Let's use a distributive property and distribute that natural log of 5 and distribute the natural log of 3. Alright, now pay attention to the way that we distribute these. Alright, when I take the natural log of 5 times x times the first term in the binomial, I'm going to write that term first. So I'm going to have an x natural log of 5. Alright, then I'm going to take natural log of 5 times the 2, that's the second term. So then I'm going to have a minus 2 natural log of 5. Okay, you want to keep things in the same order as they appear. Now, when I go to the right-hand side, I'm going to do the exact same thing. I'm going to take that natural log of 3 and multiply it by the 3x. So that's going to be my first term on the right-hand side. 3x times the natural log of 3. Plus, then I'm going to take that natural log of 3 times 2. So 2 natural log of 3. Okay, now, at this point, okay, I've got an x on the right hand side, I have an x on the left hand side. Alright, this is just basically a numerical term, and this is just a numerical term. Alright, so if I'm trying to solve for x, I need to move all of these terms with x's on the left hand side, and I need all numerical terms on the right hand side. So basically, that's going to boil down into saying, okay, this term gets moved to the left, and because it's got an x in it, and this term gets moved to the right because it's just a numerical value. Now, to avoid cluttering the paper up, I'm going to do this all in like one step without showing the opposite and crossing out. I'm going to keep whatever is originally there first. So x natural log of 5 I'm going to keep first. Now I'm going to bring this over. When I cross the equal sign, I have to do the opposite, so I'm going to subtract a 3x natural log of 3 equals, alright, now he's gone. This guy is the only one that's left on the right hand side, so 2 natural log of 3. Now I've got to move him to the other side. When I do that, I'm going to do the opposite of what I see. It says minus that, so I'm going to add 2 natural log of 5. Okay, now at this point I'm still trying to solve for x. Over here I've got 2 terms because they're separated by this minus sign right here. So I'm going to factor out the x. Alright, and I might even say that. Let's say that. Factor out the x. Okay, because you've done factoring for a long, long time at this point. So then I'm going to have an x. When I take it out of that first term, I will be left with natural log of 5. When I take the x out of this term right here, I'll be left with the 3 natural log of 3. And then I can't do anything with this expression over here because they are not like terms. So 2 natural log of 3 plus 2 natural log of 5. That's just going to stay. All right, now this says x times this quantity because I factored it out. If I'm trying to solve for x, I'm going to do the opposite of what I see. So since I see multiplication, I'm going to divide. I'm going to divide both sides by this, which means over here on the left it's going to cross out, and over here it's going to end up being on the bottom. Okay, so for my exact answer, for my exact solution, I'm going to have x equals this in my top numerator, 2 natural log of 3 plus 2 natural log of 5, and then all over what I need to divide by, natural log of 5 minus 3 natural log of 3. So there's my exact solution. All right, and then this one right here would then, if you need the approximate solution, would need to be put in your graphing calculator. All right, so definitely on this one, if you don't have a graphing calculator and you're trying to do this on scientific notation, I would definitely pause the video and see if you can get the decimal for the approximate one. If you've got the graphing TI-84 calculators, then it goes in really simple if you use that fraction button. So the approximate solution here, let's go ahead and give that decimal. X is approximately negative 3.212. All right, so like I said, if you have just a regular scientific calculator, I would definitely pause the video and try to get this in that scientific calculator correctly so that you can get that decimal. So just a few examples there of how to solve exponential equations using logs by taking the log of both sides. Definitely thanks for watching, and don't forget to subscribe to the channel. Thanks.